How to conduct structural analysis for buildings. 1. Define the scope and objectives. Begin by clearly defining the scope and objectives of the structural analysis. Identify the type of building, its intended use, and any specific requirements or constraints. Understanding these factors will guide the analysis process and ensure that all relevant aspects are considered. 2. Gather data and create a model. Collect all necessary data, including architectural plans, material properties, and load specifications. Create a detailed structural model of the building using this data. The model should accurately represent the geometry, materials, and connections within the structure. Advanced software tools like AutoCAD, Revit, or SAP 2000 can be used for modeling. 3. Identify loads and forces. Determine the various loads and forces that the building will be subjected to. This includes dead loads, permanent static loads, live loads, temporary dynamic loads, environmental loads, wind, snow, seismic, and other relevant forces. Accurate identification of these loads is crucial for a reliable structural analysis. 4. Apply load combinations. Apply the identified loads in various combinations to simulate different scenarios. Building codes and standards, such as the International Building Code, IBC, or Eurocode, provide guidelines on the appropriate load combinations to consider. These combinations help in evaluating the building's performance under different conditions. 5. Perform static analysis. Conduct a static analysis to assess the building's response to the applied loads. This involves calculating the internal forces, moments, and displacements within the structure. Static analysis helps identify critical areas and potential failure points, ensuring that the building can withstand the applied loads without excessive deformation or collapse. 6. Conduct dynamic analysis. For buildings subjected to dynamic loads, such as earthquakes or wind, perform a dynamic analysis. This includes modal analysis to determine the natural frequencies and mode shapes, and response spectrum or time history analysis to evaluate the building's response to dynamic forces. Dynamic analysis is essential for ensuring the building's safety and stability under such conditions. 7. Check structural members. Evaluate the structural members, beams, columns, slabs, etc., to ensure they can carry the calculated loads without failure. This involves checking the strength, stability, and serviceability of each member against relevant codes and standards. Make sure that all structural elements are appropriately designed and sized for their intended function. 8. Assess structural integrity. Assess the overall structural integrity of the building by analyzing the interaction between different structural elements. Ensure that the load paths are continuous and that there are no weak points or discontinuities. Consider factors like redundancy, ductility, and robustness to enhance the building's ability to withstand unexpected loads or damage. 9. Optimize the design. Based on the analysis results, optimize the structural design to improve performance and efficiency. This may involve adjusting member sizes, reinforcing critical areas, or modifying the layout to achieve a more balanced and efficient structure. Optimization helps in achieving a cost-effective design while maintaining safety and performance standards. 10. Document and review. Document all analysis results, design decisions, and calculations in a comprehensive report. Review the analysis and design with peers or senior engineers to ensure accuracy and compliance with standards. Regular reviews and peer evaluations help identify potential issues and improve the overall quality of the structural analysis. Conducting structural analysis for buildings requires a systematic approach and adherence to engineering principles and standards. By following these steps, engineers can ensure that the building is designed to be safe, efficient, and resilient, capable of withstanding various loads and forces throughout its lifespan.